How are you, my friends? This is part 4 of basic math terms dealing with exponents. I will explain some words or terms or vocabulary in exponents. So this is part 4. I have some words here like integer exponent. Please just compare number 1 and number 8. Number 1 is integer exponent. See, if you see the word integer, rational, irrational, other subset of real numbers, you can go to part 1, basic math terms. So integer means some numbers like 2, 3, 4, negative also. And here we have rational. Number 8 is rational exponent. So the exponent or the power, where the power is fraction. Rational is a fraction. We have some other words, base, power. We have the rules or laws. We have scientific notation here, number 9. Let's start. Integer exponent. So if we have a to the power n, this is the way we read it, a to the power n, it means a times a times a times a, n factors of a. See the word factor here. So n factors, the number of a repeated n times. N factors of a. A is called the base. See the word base here. N is called the exponent or the power. So we have 5 here, like an example, 5 to the power 4. The base is 5 here, and the exponent is 4. There is a little tricky question many students will face here. Look at the last line here. Minus 6 to the power 2, or minus 6 all to the power 2. See, there's a big difference here. Just be careful to understand this. You can find another video on exponents with many examples. Here only the basic terms. So I just prefer to mention this example here, little tricky example, minus 6 squared. Look here, the base is only 6 and the power is 2. So 6 power 2 is 36, and there is a minus 1. See here, the answer is minus 36. If you have a bracket, minus 6 all squared, which means minus 6 times minus 6. So here the answer is plus 36, and here the answer is minus 36. Be careful. Now, 1 over 2, which is half, to the power 5, which means half times half times half times half times half, 5 times 1 over 32 also. You can see that positive number. Now, negative exponent and zero exponent. These, they have formulas. When you have a negative, a to the power, we read this as a to the power minus n, 1 over a to the power n. That's an example, easy example. 4 to the power minus 2. Some students, they write minus 4. There is no minus here. So 4 to the power minus 2, 1 over 4 squared, according to this formula, 1 over 16. Now, a to the power 0, any real number which is not 0, to the power 0 is 1. Remember this simple formula. I put here 4 examples to see. 7 to the power 0 is 1. Minus 7 to the power 0 is minus 1. Why? There is no bracket here. See down, we have a bracket. See here, we don't have bracket. 6 y to the power 0. The power 0 on the y only, which is 1. 1 times the 6 is the 6. Just be careful, please. Some laws means rules. Sometimes we call them properties. of exponents. I just mentioned here some of them, the important four. You have other properties or laws. You can go to the video on exponents. You find all the rules, all the laws with many, many examples, simple, medium, and difficult. But here I'm mentioning the words. Some laws, like we have, let me explain just one or two. A to the power n times a to the power n. When you have the same base, you add the exponent. See here, same base, 6 and 6. You add 3 plus 4, 6 to the power 7. And when you have the same base and you divide, you subtract the power. 12 to the power 5 divided by 12 squared will be 12. 5 minus 2, 12 to the power 3, or 12 cubed. And then there are other two simple formulas there. These are laws or rules of exponents. Now remember, I mentioned at the beginning, this is number 8, rational exponent. The exponent in the power, we have a fraction like a to the power 1 over n. See the fraction here in the power? You can convert that to radicals. Nth root of a. If you have a to the power m over n, I have an example here down there, it will be the nth root of a to the power m. Now you can see a video on radicals, also basic math terms on radicals. You see the terms that are related to radicals. Let's take an example here. Suppose someone say 64 to the power 2/3, 2 over 3. Find the answer. Believe it or not, look at the answer here, 16. But you have to go through steps here. I put actually two ways to do it. You see, this is one method, 16, or another method. You will get 16 for sure, because that's the same question, same number. So let's go. 64 to the power 2 over 3. Directly, I can use this formula here. See, this number here, we call it the index. You can see it in the radical. Basic math terms. Cube root of 64 squared. You see this one here. You can put the squared outside, according to this rule here. Power m here, you can put it outside. Cube root of 64, that's 4 times 4 times 4. So this is 4 only. With power 2, 4 to the power 2 is 16. Now this is one way we can use radicals. Let's see another way. 64 to the power 2 over 3. 64 is 4 cubed to the power 2 over 3. When you have two powers, you can multiply the power. Let me show you the rules. Here, when you have two powers, see number 3, a to the power m, all to the power n, a to the power mn. You multiply the powers. Like this example here, simple example. 7 to the power 5, all to the power 4. You multiply 5 times 4, 20. 7 to the power 20. So here, you can make 64 4 cubed. Multiply now 3 times 2/3. This is multiplication of fractions. So it will be 3 times 2 over 3 will be 2. So 4 squared is 16. That's the same answer, same question, two different methods. Okay, let's see scientific notation. What is a scientific notation? It is a simple way of writing very small or very large numbers. Very small or very large number. I will tell you how to do it. You write x equals a times 10 to the power n, where a is equal to 1 and less than 10, where n is integer here. Let's see this example. 0.000003409. This is very tiny, small number. So it's not efficient to read it as I read it before, 0.00000003409. Now, one way we can do it, we move the decimal point to the right. See, that's decimal point. Move it to the right, 1, 2, 3, 4, 5, 6, 7, and then I stop. Where do I stop? At the first number between 1 and 10. So I stop there. 3 point, so it's easy now to read. Listen, 3.409 times 10 to the power minus 7. So I count the places when I move the decimal point. 7 places. And since it's a small number here, I'm moving to the right. So it is minus 7. The power here end is minus. Integer can be negative, can be positive number. Let's look at this number, 207,000,000, big number. So where's the decimal point? Decimal point is here after the last zero. So move it to the left. You see, go to the left. Don't stop at 7. We stop at 2 because 2.07, this is a number between 1 and 10. So I moved 1, 2, 3, 4, 5, 6, 7, 8. Since I'm moving to the left, that means it's a big number. So 10 to the power 8. 8 now is the integer exponent. You see, we have here exponents. That's why I put this title here, scientific notation, with the exponent, because we have exponents. And then I will show you one nice question after a few minutes, how to deal with multiplication, division of these numbers in scientific notation. Let's go to question 1, please. Evaluate the expression. Now, this exponent here, see, we have powers here. The exponent is integer. In the second question, the exponent, I will give you rational fractions in the power. The third one will be about scientific notation. 3 simple questions. Please, if you want to learn more, you can pause the video now for a minute. Replace A is equal to 3, B is equal to minus 2, there, in this whole expression. Let me read the expression. AB plus A to the power minus 1 plus A to the power minus 1, all to the power minus 1. Remember, there is a big mistake. Don't do it here, please. Big mistake in math. You cannot distribute this power minus 1 here, minus 1 multiply. You cannot, because we have addition. You can go to the, there are many videos about this. One video about exponents and simple, medium, difficult questions. You can try and study. Also, there's a basic, there's errors, basic math errors, common errors you can check. Avoid distributing the power here. Okay. So take a minute, please. Replace A by 3, B by minus 2, and the answer should be simple number or simple fraction. I'm waiting for you. I think you finished now. Try it and see the number, check your answer. The answer you should get is minus 6 over 37. I don't know if you get it. I hope you get the correct answer. Now, I did it in details here. See, AB, just a multiplication. Just put 3, multiply by minus 2. Just multiply, minus 6, finished. Now, A to the power minus 1, 3 to the power minus 1. So that's 1/3, according to the formula in the exponent. B, see, B by itself is minus 2. So you have to put a bracket. B, all of it is power minus 1. So put a bracket around the B value. B value is minus 2. So 1 over minus 2. Now in algebra, this minus 2 in the denominator, you can put it on the line here. or you can put it in the numerator like this. It's up to you. See, when you have a minus here in the denominator, you can put it in the numerator or on the line. If this is a minus, see this plus here. If this is a minus, it will be multiplied with this minus. But since we have a plus here, with this minus 2 becomes minus. Now look here, we have three numbers we need to add. I mentioned many times in many videos how to add fractions. You can check there. We need LCD, the least common denominator. So this will be 6. See, the denominator here is 1, the denominator 3, the denominator 2. We cannot add and subtract like this. We have to make the same denominator. So to make this one 6, multiply up and down by 6. Here, multiply up and down by 2. Here, multiply up and down by 3. So we get minus 36 plus 2 minus 3 over 6. Now, when you add this, you get minus 37 over 6. See, the whole power, see the question here, the whole power is minus 1. So we invert the whole fraction. So we can leave the minus 6 here, or we can say 6 over minus 37. Or minus on the line 6 over 37. That's the answer for question number 1, which is considered easy question. Let's see number 2. Find the value of this expression. Can you try for a minute, please? 16 to the power half minus 27 to the power 2 over 3 plus 8 to the power minus 1/3. You can pause the video for a minute and then try. I think now you can have an answer, and let's compare it on the next slide. So the final answer, you should get minus 9 over 2. Let's see how. Take the first term here, 16 to the power half, which is the square root of 16, only 4. Remember, when you have a square root here, only 4. 27 to the power 2 over 3. So change it to radicals, cube root of 27 squared. 27 will be 3 cubed. See, 3 cubed squared. So I can switch now to have cube root and the power here 3. See, this number here inside is 9. So this is 9 cubed. Cube root of 9 cubed is only 9. 8 to the power minus 1 over 3. Since we have a negative, 1 over 8 to the power 1/3. And this is cube root of 8, which is 2. So that will be half. So the last number is half. In the middle is minus 9. The first number is 4. Add the fraction here, minus 5 plus half, minus 9 over 2. Now the last one is about scientific notation. Nice question. I gave you here the value of the x, 0.0000032. I give you y, 20 squared times 4,000. That's y. Now what do I need? Find the value of x over y in scientific notation. So the final answer, you should give me something in scientific notation. Easy to read. You can try also this one, please, because the answer is there. Next slide. You can try yourself on a piece of paper, and then you can compare your answer. Now let's see here, the final answer you should get is 2.0 times 10 to the power minus 12. I hope many will get this answer. Let's go in details and see. The given values for the x is 0.0000032. Let's convert this x into scientific notation. So move the decimal point to the right, 1, 2, 3, 4, 5, 6. See, 3.2 times 10 to the power minus 6. Now let's look at y. Little tricky here. Y is 20 squared. 20 squared, 20 times 20 is 400 times 4,000. It's given there. So this will be 16. 4 times 4 is 16. And this is 5 zeros there. So when you convert this to scientific notation, it's 1.0 6 times 10 to the power 6. Now let's look at these numbers here. 3.2 divided by 1.6, that would be only 2. And here we have the same base. You see the idea here in the exponent? The same base is 10. So this is minus 6, subtract minus, see there's minus 6 down here, whatever the number there. It can be both are minuses, can be both are positive. So m minus the n, according to the formula. So minus 6 will be minus 12. That's the answer. Now, I will leave this for you. Find the value of this expression. This is practice number 1, nice to practice. And then another expression, practice number 2, xy to the power minus 1 minus xy all to the power minus 1. Take x minus 3, y is 5. Just little remark here. See this power minus 1 only on the y, not on the x. Just be careful. And then m is 30 squared times 4,000. And n is 0.00018. Find m over n in scientific notation, similar to the question number 3 we did together. You can practice, then you find the answers here. Okay, thank you for watching. I hope I can see you in another video with another topic. Thank you very much.